Welcome to Agentic AI World, your daily edge in AI and software engineering interviews. I'm your host, and today we're diving deep into one of the most asked topics in 2025 and 2026 AI interviews: tool use and function calling in large language models. Let's get into it. What is function calling? At its core, function calling is the ability of an LLM to decide, on its own, when to invoke an external tool, what arguments to pass, and how to integrate the result back into its response. Think of it this way. You ask an LLM, "What's the weather in New York right now?" A base LLM would hallucinate an answer. An LLM with function calling would say, "I need to call the weather API. Here's the structured JSON payload." Your application runs that API call, returns the result, and the model synthesizes a final answer. That's the loop. User prompt model decides to call a tool, your code executes, it result goes back to model final response. How it works under the hood. When you set up function calling, you provide the model with a list of tool definitions, typically as JSON schemas. Each schema describes the function name, what it does, and what parameters it accepts. For example, you might define a tool called search_products with parameters for query string, category filter, and max results. The model has been trained to output a special response format, not plain text, but a structured JSON object containing the function name and argument values when it determines a tool call is appropriate. Your application code detects this, executes the actual function, and feeds the result back to the model as a new message in the conversation. Key insight for interviews. The model itself never executes the code. It only decides what to call and with what arguments. Your application handles execution. This separation keeps the model sandboxed and safe. Parallel versus sequential tool calls. A question I see all the time. Can an LLM call multiple tools at once? Yes, modern models like GPT-4, Claude 3, and Gemini 1.5 support parallel function calling. If a user asks, "What's the weather in New York and Paris?" the model can emit two tool call objects simultaneously instead of doing them one after another. This dramatically reduces latency. Sequential tool calls happen when one tool's output feeds into the next. You can't look up order details until you've resolved the customer ID. The model handles this naturally. It waits for each result before deciding the next step. For interviews, articulate both patterns. Sequential is safer and more predictable. Parallel is faster but requires your orchestration layer to handle concurrent execution and merge results correctly. Designing your tool schemas. This is where candidates get tripped up. Bad tool schemas lead to hallucinated arguments, missed calls, and poor reliability. Best practices. Number 1. Be extremely specific in your function descriptions. Don't write search products. Write search the product catalog by keyword and optional category filter. Returns up to 20 matching products with name, price, and availability. Number 2. Use strict parameter types and enums where possible. If a status field can only be active, paused, or archived, enumerate them. This dramatically reduces model errors. Number 3. Keep tools focused. A tool that does 10 things is a tool that does nothing well. Single responsibility principle applies here too. Number 4. Handle ambiguity gracefully. Include a parameter description that tells the model what to do when the user's intent is unclear. Should it ask for clarification or use a default? Real interview scenarios. Let me walk you through 3 scenarios you might face. Scenario 1. Design a customer support bot that can look up orders, process refunds, and escalate to human agents. The answer has 3 distinct tools: get_order_status, initiate_refund, and escalate_human. Each has clear responsibilities. The escalate tool might take a reason parameter and urgency level. You discuss how you'd add guardrails. Maybe the refund tool requires a confirmation step. Maybe escalation is always logged. Scenario 2. Build an AI research assistant that can search the web, read documents, and summarize findings. Here you discuss tool chaining. Search first, then for each result, optionally read the full document. You talk about context window management. You can't feed 50 full articles back to the model, so your tool might return a summary or chunked extract rather than raw content. Scenario 3. How would you handle tool call failures? This is a great senior-level question. Your answer should cover retry logic with exponential backoff, graceful degradation, tell the model the tool failed so it can acknowledge it to the user, error categorization, transient versus permanent failures, and observability. Log every tool call, its arguments, its result, and latency. Function calling versus RAG versus agents. Be ready to compare these. They often come up together. RAG retrieves documents and stuffs them into context before the model generates a response. It's a single-step augmentation. Function calling is dynamic and multi-turn. The model actively decides when and what to retrieve or act upon during generation. Agents use function calling as the engine, but add a loop. The model keeps calling tools until it determines the task is complete. This is the REACT pattern. Reason, act, observe, repeat. For interviews, RAG is great for knowledge retrieval. Function calling is great for actions and dynamic data. Agents are great for complex, multi-step tasks. Most production systems combine all three. Key metrics to know. If you're interviewing for a senior role, know these metrics. Tool call accuracy. What percentage of the time does the model choose the right tool with correct arguments? Benchmark this. Track it per tool. Hallucinated arguments. Does the model invent values for parameters it should be leaving null? This is a signal your schema description needs improvement. Latency overhead. Each tool call adds a round trip. Measure P50, P95, P99. Know when parallel calling makes sense to cut latency. Token efficiency. Tool definitions consume context tokens. Prune and use tools from the schema at runtime based on conversation context. Closing. Here's your 3-sentence summary to lock this in. Function calling gives LLMs the ability to invoke external tools by outputting structured JSON. Your code handles execution, not the model. Great tool schemas are specific, typed, and single responsibility. In production, handle failures gracefully, log everything, and benchmark tool accuracy as a first-class metric. That's today's episode of Agentic AI World. Hit subscribe so you never miss a daily prep session, and I'll see you tomorrow.